Hi, it's Sam. In this video, we're going to be looking at how to implement ratcheting with MIDI. And ratcheting is basically taking a step, if it's a sequence or a note, and dividing it into equal parts. So this is the code that we're going to be implementing today, and let's just take it different parts of it as we go. So first we need a integer box that's going to represent the number of ratchets. And 1 is going to be equivalent to no ratcheting. And maybe I'll just set a maximum of 8 for this, but you could do more if you wanted to. And we need to get the length of each ratchet, which is what we're going to use for this pipe later on. We'll see how that works. But we'll need to know the length of each ratchet in milliseconds. So to get that, we're going to take the length of each step or each note that we're outputting. So let's pretend that we're using a sequencer that is outputting quarter notes. We have a quarter note rate. We're going to translate those quarter notes to milliseconds. And then we are going to take the length of the step or note or whatever it is and divide it by the number of ratchets to get the length of each ratchet. So I need to use bang division here. So we'll go in here. We're going to make sure that it updates every time that this value changes by using this trigger. And this will give us the length in milliseconds, length of each ratchet in milliseconds. So it'll be 600 milliseconds. That means that we're also not going to have any ratchets. Now, if we have 2 ratchets, it'll give us 300 milliseconds per note, 200 for 3, etc. And what we're going to do is send this to multiplication. And this is going to help us to get the milliseconds delay for pipe. So what pipe does, if you're not familiar with it, is it takes a message and it delays it for a certain amount of time. So we're going to delay the message, which will be the pitch, for a certain amount of time. And in order to get those different time values and to process them, we're going to be using Uzi. And we're just going to give it a default value of 16. And then I want it to start at 0. So by default, it starts at 1. At the very right here, we get the current index of the bang that's coming out, which is really helpful because this will give us an ascending 0 to 15 if it was 16. And we can use this to get the delay values for pipe. So first it'll be 0. So the first delay value will just be 0, start immediately. And then the next one, it'll do 1. So 1 times whatever the length is. So for example, if we had 2 ratchets, then first it'll be 0 times 300. Okay, starting at 0, which is what we want. We want it to start immediately. The first note will start immediately. And then the second ratchet will start at 1. That'll be the next index to come out of Uzi. 1 times 300 will just be 300, so it'll be delayed by 300 milliseconds. And then we have those evenly divided ratchets. And so I need to send the number of ratchets to the right inlet, which is how many bangs that the Uzi is going to shoot out. So let me just make sure to update that. So it'll be 2. Now we also need to supply a message that's going to be set to pipe. And that what that's going to be is our pitch. So we're going to send from Uzi. We're going to get the pitch. I'm just going to store the pitch in this integer box. And we're just going to put this in the cold inlet so it's stored, but we don't want to send it out, though. We're just going to set it here. I'll set it to middle C right now. It's always good practice, I guess, to set up a load mess so that there's some default value. So we'll just do that. And then we also need to make sure that we have a way to start the ratchets. So we can use this bang right here to start the process. So now we just need to send this to our make note, and I'll give it a argument of 127. That'll be the velocity, just full velocity. And I'm going to turn repeat mode on to 1, which is what I typically do, which makes it so that if a note's playing and it gets the same pitch, then it will stop the previous note and then start the note that it just got. And then we need to send the duration. So the duration is just going to be whatever the length of each ratchet is. And then this just goes to note out. Okay, so let's give this a try. Everything should be initialized now. So let's start with just like 1. Okay, now let's try 2. And 3. 4. 5. 6. 7. And 8. So as you can see here, we got the length of the ratchet by just taking the length of the step and dividing it by the number of ratchets. And then to get these equally spaced ratchet delay times, we just took the index from Uzi and multiplied that by the length of each ratchet. And because Uzi starts at 1 by default for the index, we can change that to start at whatever number we want using the second argument. So we made it start at 0 because we want the first the first pitch coming out of pipe to be sent out immediately. So it would be like on the beat. There's just one kind of caveat to this system, which is you would need to tweak the length of the step if you're using swing, because swung notes would be shorter and non-swung ones would be longer. So this only works if every step is the same length. Otherwise, you would have to set up some logic to check, is this a swung note or not? And if it is, how much longer or shorter does it need to be based on that? So that's one thing to keep in mind if you are setting this up, is that you'd have to put in something to account for that. Well, I hope you found this useful. Please let me know if you have any questions or need any clarifications. Otherwise, until next time, class is dismissed.